section 5.5, we're going to start adding and subtracting polynomials. The way this is going to work is that we're going to combine things that have like terms. So let's understand what it means to have like terms. Polynomials have like terms if they have the same degree and same variable. So for instance, in problem number 14, both of these terms have an x squared. Now, I'm going to show you the long way first. In fact, don't even copy it down. One thing that I could do, if I wanted to, would be factor out the x squared. It's a common factor. That would be 15 plus 10 times x squared. 15 plus 10, of course, is 25. So I end up with 25x squared. So the part that I want you to do is this. When you have like terms, I want you to add up their coefficients. The reason I did it this way is so that we can conclusively see that I don't get 25x to the fourth. Under what circumstances would I get an x to the fourth here? Yeah, if it was multiplication, then I get an x to the fourth. But with addition, you're just going to add up the like terms. So let's take a look at problem number 18 then. Negative 3y squared minus y minus 6y squared plus 7y. It's not really written, but what variable or what coefficient is understood to be here with the negative y? 1. Negative 1, yeah. So, or yeah, this part's a 1 and then there's a negative in front of it. However you want to see it. Negative 3y squared minus 1y minus 6y squared plus 7y. Now what I suggest to you, and what I sometimes do for myself, is this. I underline the like terms. So what's the like term with the minus 3y squared? The minus 6y squared. And then these terms are also like terms. So let's combine these and see what we get. Close. Negative 3 plus negative 6 would be negative 9. All right. And then how about over here? Negative 1 plus 7 gives you 6y. Now, I'm not worried about the fact that these have common factors or anything like that. Can I add this together further and get maybe, I don't know, negative 3y to the third power or something like that? No. These aren't like terms. That's it. That's as far as we can go here. Let's try a different one. Problem number 22. 1.9 m to the fourth minus 2.4 m to the sixth minus 3.7 m to the fourth plus 2.8 m to the sixth. What degree polynomial is this? A little review from the last section. What's the degree of this polynomial? 6. It's the highest degree monomial term that you see. This is kind of like problem number 18 in as much as you're going to combine like terms. That would be these two, and of course these two. Now I see a bunch of you taking out your graphing calculators and other calculators. That's great. Nothing wrong with that. So let's see. We want 1.9 minus 3.7. That's what? Negative 1.8. Negative 1.8 m to the fourth. And then negative 2.4 plus 2.8. That'd be 0.4 m to the sixth. Now, I'm not going to mark it wrong if you write it like this. Generally speaking, you write them in descending order, so it'd be 0.4 m to the sixth minus 1.8 m to the fourth. I mean, that'd be preferred. The only time that you'd be taken down a point is if I specifically state in the problem write your answer in descending order. If I explicitly ask for it, then I do expect it. Other than that, this is a good habit to be into. Write them in descending order, but it's not necessarily mandatory. Let's try a few more. Problems number 24 and 30. 24 is 2/5 AT plus 1/5 AT. I think I might write 30 with X's as opposed to T's. I'm just not a big fan of T's because T's look too much like pluses, at least in my chicken scratch. So let's write problem 30 with X's. 2x cubed plus 11x minus 15 plus negative 5x cubed minus 13x plus 10. So as with the previous ones, we want to combine like terms. Do I have like terms in problem 24? Can I just add those together? Cool. So what do I get? 3/5 AT. Perfect. Just add them together. In fact, they even had common denominators. How sweet is that? Now with the second one, again, there's like terms. There's an x cubed that's in common. There's an x that's in common. And then there's the constant terms. Micah, what's the sum of the first two going to give me? Good, negative 3x cubed. Let's keep going back. Nick? Plus 6x. Wait a minute. Okay. So 11 plus negative 13 gives you negative 2. Good. So negative 2x. And then last but not least, negative 15 and 10 gives you a negative 5. Wow. Cool. Faster than a Matt Stafford comeback. Not bad. Let's keep going. Problem number 34. Negative 0.3 R minus 5.2 S plus 0.8 S minus 5.2. Is that S? Oh, you know what? I think this should be an R. So that should be an R. Let me just double check that. Yeah, 0.8 R minus 5.2 S. There's a minus here. So more of the same. So what do we get when we combine negative 0.3 and 0.8? All right, so 0.5R minus what? Or does that turn into 0? Good, 10.4. So 10.4S will be the rest of your like term here. Now earlier in section 5.4 we talked about polynomials. We've been working with polynomials and binomials in this section, although we haven't referred to them by those names. Let's work with something else. In talking about polynomials, I talked about, the word poly. Let's talk about another word, perimeter. So perimeter, again, a word made up of a couple roots. Peri means around. Your heart is surrounded by a special skin called the pericardium. So peri means around. Meter means distance. So perimeter, perimeter means distance around. And let's think about that when we look at problem number 38. Let me put that up on the board here for you. Okay, so if I want the distance around, it's going to mean adding up this plus this plus this. They didn't really tell me what's going on over here, did they? Did it tell me how long this side was? Good. It's going to be the same as this side, right? Because their angles are the same, so the sides have to have the same length. So even though it's not written, it's going to be x squared plus 3x plus 1. I have to add up that plus this to get the perimeter, that is the distance around. So let's do that. Problem 38. I'm going to have x squared plus 3x plus 1. That's one side. I get that same side again because this is an isosceles triangle, meaning it has two sides the same. And the last side is x squared minus 4. Oh, I'm sorry. Yeah, I did 37. Wow, this is really bad. I'm actually doing one of your homeworks. Please forgive me. All right, so problem 37. Yes. Well, same thing going on. And that's actually kind of a good mistake here. I kind of like that we're doing this one. Because something unusual is going to happen, at least something a little different here, as opposed to some of our other ones. What do I get when I combine like terms amongst the x squareds? Well done. 3x squared. Even though it's not written, it's understood that there's a coefficient of 1 for all of these. So 1, 1, and 1. 1 plus 1 plus 1, 3x squared. All right, good. So 3x squared. Are there any other like terms, Don? Is there anything else that I can combine? All right. So go here, 1, 1, and negative 4. 1, 1, and negative 4 gives me negative 2. And I've been saving one last one here. Thank you, 6x. So, cool. Your weekend got that much more roomier. All right. How are we looking on 37? Okay there? Now, we don't always add like terms, or we don't always add our polynomials horizontally. Sometimes we add them vertically. So let's practice a couple like that. I'll do problem number 42. I'll let you do problem 46. I think you'll see pretty quickly that it's nice to have them stacked vertically. Six x cubed minus 4x squared plus 7. And we're going to add 7x cubed plus 9x squared plus 12. Okay, well, wow. Can anyone spot something that's kind of nice about this? Yeah, they're all lined up, right? So this is another reason that it's good to write these in descending order. If they weren't descending order, then they wouldn't all line up. But they do line up. And now we can just add straight down. That's going to be a 19. What's negative 4 plus 9? Positive 5. and then 13x to the third. Notice that what I didn't do, I didn't add the exponents. You're just adding the coefficients. Do not add the exponents. Wow. Hey.
That was easy.
Yes. Good deal. Let's try problem number 46 now. You try problem 46. 3x cubed plus 4x squared minus 3x plus 5. We're going to add that to 3x cubed minus 4x squared minus x plus 7. Sean, want to do that one? Go ahead. It does. So you got two choices. You could write 0x squared, or you could just leave it off entirely. I'd probably prefer to just leave it off entirely. But it's up to you. You want to do the rest? Good? Perfect. So you can write this or 6x cubed minus 4x plus 12. If I was writing out an answer key for a test like this, I'd probably use the latter one. If you wrote this, that's fine too. Doesn't bother me at all if you want to write it like that. What's wrong? Should have been a negative. All right, so it's problem 46 prime. All right, so it's not exactly 46, but it's what the author really wanted. They just screwed up with the printing press. All right. Let's work with subtraction. Subtraction is going to make a little bit of a difference for us. So subtraction of polynomials. We'll start with problem number 50. 2b squared plus 3b minus 5 minus 2b squared minus 4b minus 9. The thing about subtraction that I would suggest to you is that the first step would be to just distribute this sign. This is like a -1 out in front, so what we're going to do is we're going to change all the signs on this term. Yes, sir? Pretty much, yeah. And I'm going to get rid of the parentheses. I'm going to write this as 2b squared plus 3b minus 5 minus 2b squared plus 4b plus 9. Now that I've distributed this, now I can just add them up like before. But you can't combine like terms until you distribute this. You have to account for that negative. Well done. Those cancel out together, right? This is completely gone. And then you're right. 3 and 4 gives me 7. 7b minus 5 and plus 9 gives you a plus 4. Done. So the important thing to work on here is that you've got to distribute to that second polynomial. Distribute the negative sign. Change the signs, then add. Now what we're eventually working to is to do some vertical subtraction. And that's where it's going to get a little bit tricky. Not hard, but hard enough. And we're going to want to practice that because it's going to come back at us later. for now, let's try problem 52. Negative c to the fifth plus 5c to the fourth minus 12 minus 2c to the fifth minus c to the fourth. So like the last one, distribute that negative first. And then see about combining like terms. If I distribute the negative sign, Victoria, what would I get? All right. What are the like terms that I can combine here? Karanja? So, Karanja, what do I get when I combine like terms, please? All right, so negative 3c to the fifth. And let's see, we've got 5 plus what? Good. 5 plus 1 gives me 6c to the fourth. Minus 12, there's no like terms there, right? So just leave it, minus 12. And that's it. Thank you, sir. Now, I got a little note here to try and help us remember something. When you subtract A from B, the order is B minus A. Let's keep that in mind as we do problem number 60. Let me throw that up on the board here for you. Let's try again. There. Subtract this from this. So which one goes first? The trinomial or the binomial? Binomial. Good. So let's write that down and then simplify it. So 10p squared minus 30 minus 4p squared minus 4p minus 40. Distribute the negative sign, clean things up a little bit. Andrew, what am I going to get when I distribute the negative sign? Perfect. Thank you, sir. And we've got like terms here, right, Don? What can I add up? Or what can I combine? All right. So 10p squared minus 4p squared gives me 6p squared. Good. Are there any like terms I can combine? Other like terms? Minus 30 and 40. Now left out of this is the 4p. So let me just squeeze that in here. 4p plus 10. Nice. The big thing when you're subtracting is we just distribute this so that we can add them up. We're going to do a lot of what I call change the signs then add. Yes?
So actually when we do the subtraction, we take the bigger number, we subtract the smaller number from the bigger number. Is that what you're saying? Like you go with a 40
Well, the way I work this one here is I regarded this as an addition, negative 40 plus negative 30 plus 40. So negative 30 plus 40. Remember way back at the beginning of the semester when we started dealing with stuff like this. When you're adding numbers that have mixed sign, subtract the smaller from the larger and keep the sign for the bigger. Yeah, so that's exactly what we're doing. Here's where they're going to get a little bit interesting. Let's look at problem number 63. And I got to confess that I think I'm doing one of your homeworks again. That's okay. You should probably take another look at it at home, but at least you can look back at the video or your notes. So 63, 0.8x cubed minus 2.3x plus 0.6 minus 0.2 x cubed minus 1.2 x squared minus 3.6x plus 0.9. So once again, we're subtracting. What that's going to mean for us, and I know it's a little bit of a pain, you don't have to do it as long as, or take as long to do it as I'm going to. We need to distribute this sign to all of these. So it's going to be 0.8 x cubed minus 2.3x plus 0.6 minus 0.2 x cubed plus 1.2x squared plus 3.6x minus 0.9. So what did I do here? Change the signs, then add. Change the signs, then add. It's a great question. There's a gap here because in this polynomials there's no x squared terms. So you don't, but if you didn't write a gap, then this is what you would face. You'd have, let's see here. If we didn't write the gap, it'd be 0.8 x cubed minus 2.3x plus 0.6. And it's a great question. I appreciate you asking that. I've not been asked one like this before. Plus 1.2 x squared plus 3.6 minus 0.9. So if I didn't write the gap, look what happens. I don't have the like terms stacked on top of each other anymore, right? So it's like, well, wait a minute. I need to add this and what? Or this and what? You know, so I think this should have been an x, but still, it's not as convenient. So the reason we put the gap there is just so that the like terms line up. Okay. Big E, want to do this one?
0.6x cubed plus 1.2x. So that's, yeah, plus 1.2x squared plus 1.3x minus.
Perfect. So once you distribute that negative sign, it's just a matter of change the signs and then add. So let's do problem 64. See how you do there. 9.7y cubed plus y plus 1.1. And kind of like the last one, I'm going to do another subtraction problem. Minus 6.3y cubed minus 4.4y squared plus 2.7y, oops, 2.7y plus 8.8. And that's just a little bit of a typo here. Yeah, it's up to you to distribute.
So I wonder how sensitive the mic is. So I wonder how sensitive the mic is.
I guess you'll find out.
I guess so. Yeah, plus. Currently it's plus 2.
Okay, so we need to distribute that negative sign. That's going to change all the signs here. So that'll be a minus 6.3, a plus 4.4, a minus 2.7, and a minus 8.8. The rest of it is just adding up like terms. So first one I get is what? 3.4y cubed. The next two are kind of gimmies, right? Well, at least the first one. How about this one? Good, thank you. Negative 1.7y minus what? 7.7. How many got that one right? All right, happy note to end on. Let me give you some homework. Homework 11 through 51, 55 through 75, 81 through 85, and 97 has an asterisk by it. I don't know what that means. That's section 5.5.